Hello dear students, how are you all? Hope you are safe and sound at your places. I am Dr. Swarndeep, your chemistry faculty, and let's learn today about a very interesting topic in organic chemistry, which is aromaticity. Now, what is aromaticity? Where does the word arise from, right? What is the origin of the word? What are aromatic compounds, right? And what are the questions which usually come in your IIT JEE mains and advanced and also NEET level examinations? We will discuss all of that right in this lecture. So let us start. So aromaticity, the word, it arises from the Greek word aroma. Aroma means a specific odor. Like you must have seen, there is a specific aroma in the spice box kept in the kitchen. There is a specific aroma in perfumes, right? So as science progressed, so this particular word aroma, this particular assignment of aroma to certain compounds, the definition graduated from that, and it turned out, as we studied in the previous classes, in the classification of organic compounds, we have studied there's a category of organic compounds which is aromatic compounds. Aromatic compounds now were classified as the compounds having lot of conjugation. That means a lot of unsaturation in them. That means the double bonds are alternate and there is a lot of delocalization of pi electrons, and also they are cyclic compounds. So in totality, they are cyclic compounds. They are conjugated with a lot of unsaturation. They have delocalized pi electrons, right? So this is also the first first level of classification of by which we can classify certain compounds into the fact that they are aromatic, right? And the property of having these properties, that is known as aromaticity. So the aromatic compounds must be cyclic, conjugated, having a lot of unsaturation, and they must be with delocalized pi electrons. Also, you will realize that aromatic compounds, although having unsaturation, they do not give you typical reactions of acyclic organic compounds which have unsaturation, which is alkenes and alkynes, which is due to the unusual thermodynamic stability given to them by the virtue of conjugated double bonds. That is the reason why they would rather not give the typical reactions such as addition reactions given by alkenes and alkynes. They would rather give you substitution reactions, right? So let us go into more detailed analysis of aromaticity of certain compounds, and let us discuss first of all how can we classify aromatic compounds, how certain compounds are aromatic, and if they are not, let us say they classify into some of these conditions yet they are not aromatic, they can be either anti-aromatic and non-aromatic. And some examples I will take of the word called quasi-aromatic, right, which is also an important topic. Now let us learn what are the few criteria for calling a compound aromatic and how we can calculate on the basis of double bonds which are present. So first of all, aromatic compounds, as I described in the first category, they are cyclic, conjugated, highly unsaturated compounds, right? And the second one is that they are planar. As we have studied, the systems with double bonds, they are sp2 hybridized, right? So this means in totality that each and every single carbon in a cyclic unsaturated system will be sp2 hybridized. There will be a lot of unsaturation, conjugated double bonds will be there, and delocalization of pi electrons will be there. The most famous system that we know of obviously is benzene. Here you can see, as I will show you here in this structure, that you can see that imagine these long bonds to be the double bonds, right? These are the hydrogens, the ones attached to the white bonds, right? So you can see that they are all lying in one plane, right? And they are sp2 hybridized. So conjugated double bonds and planar. Yes, these are the two conditions. And what is the third condition, students? Third condition is called the Huckel's rule. Huckel's rule says that for any compound to be aromatic, these two conditions should be there. That means cyclic conjugated, right? Delocalized pi electrons, and they must be planar. And the third is it must have 4n plus 2 pi electrons. Or we can say odd number of pi bonds. See the number of pi bonds here in benzene, 1, 2 and 3. So it has 4n plus 2 pi electrons. Let us calculate, students. The value of n here should be either 0, 1, 2, 3 or 4. Let us calculate the value of n. 4n plus 2 pi is equal to, we have 6 electrons here. 2 electrons per pi bond, right? So what is the value of n here? 6 minus 2 divided by 4, which is 1, right? That means it classifies into a proper aromatic compound. That means it is a cyclic compound conjugated with double bonds. It is planar in nature. It has 4n plus 2 pi electrons, where the value of n is 0 and all positive integers. Right, students? These are the few criteria apart from this which classifies a system into aromatic system. Other compounds which may be having one of these criteria and may not have the other ones can be classified into anti-aromatic and non-aromatic. Now let us discuss something about anti-aromatic systems. Anti-aromatic systems will have cyclic conjugated double bonds. They will have unsaturation. They will have delocalized pi electrons. They will be cyclic systems. They will be planar too. They will be sp2 hybridized. However, they will only have 4n pi electrons. That means they will have even pi bonds, right? They will have even pi bonds. They will have 4n pi electrons. That is where you can differentiate between aromatic compounds and anti-aromatic compound, students, right? Now, we will go into the third category, which is the non-aromatic. They are also cyclic. They will also have conjugated systems, right? They will have they will be having unsaturation. They will be cyclic, but they will not be planar. One of the atoms in the cyclic system will go out of the plane of the paper. Thus, conjugation is lost, right? So, conjugation is lost in that. So, they may or may not have 4n pi electrons. Alright, students. So, you have been given this first introduction into aromaticity. Now, we will go into more details. We will practice more questions and we will see how we can classify various given systems into aromatic systems, into non-aromatic systems, into anti-aromatic systems, and how, based on a given structures, this can be elucidated, right? So let us move. Let us now, students, discuss various compounds. First is, like we discussed, benzene, right? We discussed benzene. We know that it is planar, conjugated system, right? And also we know that it has 4n plus 2 pi electrons. It falls into the category of the compounds which follow the Huckel's rule, right? So now, students, we will discuss certain examples which will give you more clarity into how to classify a certain aromatic compound into those three categories, whether that compound is really aromatic, anti-aromatic or non-aromatic. Any compound having a cyclic system, conjugated system, that is difficult to decide whether it's really aromatic, whether it falls into the category of anti-aromatic or non-aromatic. So let us discuss, after we have discussed those rules, right? Earlier we have discussed this rules of how to categorize a certain compound into aromatic, anti-aromatic or non-aromatic. So let us now start with the first compound, which is pyrrole, right? So this compound, if you clearly see, how many pi electrons does it have, right? Let us see. So there are 2 pi bonds, that makes it 4 pi electrons, right? There are 2 electrons in nitrogen too. Can you see? And this makes the entire system planar, right? They also participate in conjugation in this structure to make it conjugated system, to make it aromatic. Thus, the entire system is planar. These 2 electrons participate in conjugation. Thus, there are 6 pi electrons participating, right? Thus, the system becomes aromatic, right? So, because of the 6 pi electrons, it follows the 4n plus 2 pi electron rule, which is the Huckel's rule, as you remember, right? The second example is, students, benzene. As we have discussed earlier also when we were discussing the rules. So again, 6 pi electrons, all atoms are sp2 hybridized, conjugated double bond system, delocalized pi electrons are there, 6 pi electrons, again 4n plus 2 pi electron rule is followed. That is the Huckel's rule. Thus, this compound is also aromatic. Now, there is another compound which is known as benzyne. It's an intermediate in a reaction which you will read in class 12, which is Dow's process, right? In the synthesis of phenol, right? So, you'll encounter this intermediate again over there. So, again, now you will see that in this particular structure, there are, can you see how many pi electrons are there? Can you count, students? 2, 4, 6, 8. Is it really 8 pi electrons? No. Actually, if you see, then that this pi bond, the one which I am encircling, which is outside, which is shown outside the ring, it is formed by the overlap of two sp2 hybrid orbitals, right? And they are strained. They are tilted and they are strained. So, thus they fall out of the planar ring. There are only 6 electrons or 3 pi bonds in the planar ring. Thus, this system is aromatic, right? These 2 electrons do not participate in conjugation. Thus, it is aromatic, right, students? So, do not get confused once you see a structure. Just think logically and you will find out the answer based on the concepts that have been taught to you, right? Okay, students, let us fall to the next example, which is the cyclopentadienyl cation. So these are 5 carbons, 2 double bonds which are there. So is this really aromatic or not? Let us see. So there are 2 pi bonds, that means 4 pi electrons, right? What did we say about those systems which have 4n pi electrons, right? And they are also planar, they are also conjugated systems. You remember they were called anti-aromatic. They do not obey the Huckel's rule, right? So it is anti-aromatic. They do not obey this 4n plus 2 pi electron rule. They are anti-aromatic. They are planar. They have conjugated pi bonds, pi electrons, but they are anti-aromatic. Okay. So next one is cyclopentadienyl anion. Anion with a negative charge on it, right? So now how many electrons are there? Now you can count 2, 4 and 6 electrons, right? So 6 electrons mean 4n plus 2 pi electron rule is definitely obeyed. Thus this system is aromatic. Now you see there is a difference of charge. One is a cation, another is an anion. So that makes it one is anti-aromatic, the other one is aromatic. So now you have to choose very, very carefully. Just 2 or 3 rules and we will be seeing how the things change, right? So let us go on to the next example, which is cyclooctatetraene, right? It's a 8-membered cyclic structure having 4 double bonds. So that means there are 8 pi electrons. 4 and pi 2, that means 8 pi electrons. 4 and pi, that means 8 electrons are there. But you must be thinking now, ma'am said that it should be planar, right? The structure should be having 4n pi electrons, it should be cyclic, it should be conjugated double bonds. Then why has ma'am written non-aromatic over there? So students, here I would like to tell you one thing. It's a huge cyclic system. So such systems often go out of planarity. They assume a non-planar form. Imagine this one going like this, right? So when some of the atoms, some of the bonds fall out of the plane, they no longer fall in the category of anti-aromatic. They fall in the category of non-aromatic, right? So somewhere you have to remember also that what the cyclic structure is doing to the compound, apart from the calculation of pi electrons, apart from, seeing the cyclic structure, the conjugation, etc. Let us go to the next example. Now this is cyclobutadiene. So this is a small ring, 4n pi electrons, 4 pi electrons, n is equal to, right? So 4 electrons are there, n is equal to 1. So 4 pi electrons, 4 pi electrons, right? So the system is anti-aromatic. It is planar. It is not non-planar. It is not tub-shaped like cyclooctatetraene. Remember that, right? Again, the next example now, it is known as naphthalene. You must have seen those small white balls which your mother must be keeping with the winter clothes or with some of her good expensive saris, right? So that they're known as mothballs. They're also known as mothballs. So they protect from, they have anti-moth activity. So they kill the germs which eat away the expensive clothes or the woolen clothes, right? So this is the function of naphthalene, and you can see here, this is the structure of naphthalene. As you can see, there are 10 pi electrons. That means 5 bonds. As I told you, there are odd pi bonds. So definitely the structure is aromatic, right, students? All carbons are planar. All this entire structure is planar. Now I am not saying that this is a single ring. These are 2 rings. So don't think that this has similarity. This is not a big ring. These are 2 6-membered rings, right? So they are aromatic. The ninth compound, second but last, right? So this is anthracene. Anthracene is also 3 benzene rings joined together. So how many pi electrons are there? See, 1, 2, 3, 4, 5, 6, 7. Odd number of pi bonds, 14 electrons. 4n plus 2 pi electron system is there. 4n plus 2 pi electron rule, that is Huckel rule, is obeyed. So this is an aromatic system. Let us come to this cycloheptatrienyl cation. So there are 3 pi bonds. Can you see? 3 pi bonds, right? Odd number of pi bonds. So 6 pi electrons. This plus charge, carbocations. So carbocation is sp2 hybridase. So this carbon is sp2 hybridase. This makes the entire structure planar. So it is aromatic, students. Okay. So these are the few examples that I have taken, and now you can, with more practice, you can easily justify and classify the compounds into aromatic, non-aromatic and diaromatic